Hey everybody, welcome back to the channel. In today's video, I have a very cool Sansui AU-717 in for a full restoration. This was sent to me from TJ. He's a stereo reviewer on YouTube who recently saw some of my videos and reached out to me regarding this. He wants this thing fully rebuilt from top to bottom, and I thought it would be pretty cool to bring you guys through the process and show you what goes into a restoration of one of these. It's a pretty complex amplifier. It has a lot of circuitry for phono stages, line stages, as well as your power supply, amplifier modules. So it's going to be pretty thorough restoration. I'll have a lot to do. He also wants me to replace the spring clips on the back for proper 5-way binding posts. So we'll get those replaced. He also wants the lamp cord cut off, and he wants an IC inlet installed on the back. So we'll get that done too. Just general cleaning as well. This thing's in pretty good shape, but there are some smudges and scratches on it that can be polished up. I think these vents on the top right here might be dented in a little bit. I'll have to take care of those. Polish up the RCA jacks on the back. But yeah, it's going to be a pretty thorough restoration. This might be a long video, but I'm going to try to condense it down like I usually do. But judging from the last few videos that I did, I'm not really too good at shortening videos. I think the last one I did was almost an hour long, so. But we'll see. This amplifier is in really good shape. It has some smudges on it, but those should clean up pretty well. The first thing I'm going to do is open this thing up and inspect it for shipping damage. I know TJ used this a lot, so theoretically it should work, but who knows what happened in shipping. It was packed well. There's no damage anywhere from shipping. I've already inspected the outside of this thing, so I mean there's small little things here and there, but by and large it's fantastic. So let's get this thing opened up and let's take a look inside. So I just got done taking a look on the inside, making sure nothing was out of place. Everything seems to be in good condition, so I have it plugged in right now. I have my signal generator and my oscilloscope hooked up, and I'm just going to feed in a small signal, 1000 hertz. Right now I'm just going to isolate the preamp and make sure the preamp is passing signal. That is if it works. I haven't even turned it on yet, so let's do that right now. Okay, so it came out of protection mode, and I'm hooked up to auxiliary right now, so let's flip down to auxiliary. And yeah, I have a signal. Nice and clean. Let's change the balance. Oh yeah, I got some noise. Both channels seem to be tracking pretty evenly, even at the bottom. Maybe a little bit of noise in the potentiometer, but overall it seems pretty good. And this is just the preamp, so I don't know if the power amp is passing signal or not. But so far so good. Just gonna change the source. Tape. Tape doesn't do anything. So maybe the balance is a little bit dirty. Loudness. High filter, low filter. Tone. Tone switch is dirty. Turn the tone on. Yep, treble pot's dirty. But yeah, so far so good. No smoke, and it's passing signal through the preamp. So let's get the power amp hooked up and see if that works. Before I do that, I'm actually going to test the phono stage and all the other inputs, make sure those all pass signal, and I'll come back after I do that. But yeah, anyway, this thing's in really good shape internally. Looks really good. It kind of smells like a cigarette, so I'm gonna have to clean all these boards off, get the flux off of there, because that's where most of that smell is coming from. The flux just absorbs the nicotine stench, and yeah, we'll get that taken care of. This is a military postal exchange, or military PX amplifier. That's where it originated from. And I followed the gentleman that owned it all over the world, apparently. And it looks like he never really got much use out of it. There's no heat stress to the boards. There's no bulging capacitors. The filter caps haven't leaked yet, which is surprising, but we're going to change those out anyway. They're probably way down on C and high on ESR. So like I said, I'll come back when I finish up the preamp and move to the amplifier, make sure that works. I'm back with the 717. I have both channels loaded down to 8 ohms, and I'm about to measure the output with my oscilloscope. So let's bring it up and see if both channels are passing signal. And there we go. Nice clean sine wave. Let's bring it up to clipping. Oh, there's clipping right there. So drop it down one click. And we're over 28 volts, 28.5, even more than that. So this thing is passing more than 100 watts per channel. And it's only rated for 85. And keep in mind, this is unrestored too. So this thing's performing well. So it's going to be a good candidate for a restoration. I'm going to start by disassembling the amplifier, get everything torn down. I think that's probably going to be the easiest way. Get the power supply out, the amplifier cards, the phono stage, and the line stage. I might change my mind as I go, but I think that's what I'm going to do. Get all the covers off. But yeah, that's very good news. This thing is working pretty well, as you can see by the very clean sine wave. And that's coming out of the power amp. So, good news. I will come back when I start the disassembly process. Okay, so I made some progress in the past 30 minutes. I have the faceplate off with the knobs and switches removed. I have the shrouds on the top pulled off as well, for the phono stage and for the line stage and volume control and all that. And I've been taking a lot of detailed photos for, the disassembly process to make it easier to get everything back together. Here's the bottom side. I just labeled all the wires and took a bunch of pictures, so it's going to be pretty easy to get this all back together. I won't be struggling to figure out which one goes where, which wire goes where. So I'm going to pull these pins off, desolder these wires, and then pull these amplifier modules out completely. So that'll be the first step. Alright, I have the amplifier modules out. That was pretty easy. All I had to do was disconnect these pin connectors at the bottom, and they both came right out. So now that those are out, I have a lot more room to work on the power supply. And I'm going to have to desolder every single wire on this board to get this out. Some people work around these boards, but I figure it'll be easier just to desolder these wires and get it out of the way, and then have full access to the board without trying to work around them. That's usually what I have the best luck with. So that's what I'm going to do here. And then I'm going to put the new filters in with the new bypass caps as well. I'll save that for after I get the power supply back in. And then I'll move over to the amplifier modules and get those sorted. Should be pretty simple. And then after all that's done, I'm going to move on to the phono stage and flat amp, as well as the tone control amp right here. And then move on to the rear panel. I did notice that I really don't have too much room to install binding posts, so that's going to be pretty interesting. Try to figure that out. And the RCA jacks are mounted to a circuit board, so I'm not going to go through the hassle of installing new RCA jacks unless this thing totally needs it, which it very likely doesn't. So I'm just going to polish these up and make them look like new. So I'll come back shortly with another update. Alright, it's the next day. I'm back working on the Sansui AU-717. I have the amplifier modules pulled out, as well as the power supply and the input board. And I have them all sitting right here. This is the input board. There's nothing majorly wrong with this. There's no corrosive glue on it. It's just going to need a full rebuild, recap, probably replace a few signal transistors, reflow it as well. It's pretty dirty. So I'll make that look like brand new and clean the switches too. The amplifier modules are going to be pretty straightforward. Basic stuff on these, like a recap. Replace a few of the fusible resistors, scrape all that glue, reflow them, remount the driver transistors on new thermal interfaces, reflow the back of the board, and then I'm going to redo the thermal interface. I'm going to clean the heat sinks. These are pretty dirty. There's not a lot of corrosion on this board yet. A few of the components are, but nothing serious. What's weird is the glue on this board has activated, for lack of a better word, and it started corroding some components. But if you look at this board, the glue is a totally different color. It's like it's still a tan color, and nothing started to corrode yet around the glue. So it's weird how environmental factors can play a role in things like this. You know, the difference in heat from this board to this board probably is what caused this versus that. But anyway, so I'll get these done. I'll probably do these first, and I'll give you an update as I go through that. And then the power supply is going to need the most amount of work. This is filled with corrosive glue, and there's a lot of components that are just totally damaged. We have a lot of VD1212s that I have to replace with a couple diodes in series. Just going to get a new relay. But if you just see the amount of components that are damaged by this corrosive glue, including diodes, that's not good. Transistors, capacitors. Not good. And the back of the board is filthy too. Lots of stuff needs to be done. This is probably going to take a few hours just to do this one board alone. There's just so much to do. So I unsoldered all the wires from this board from the chassis. So I was able to remove this board. And it turns out it's a lot easier that way than working around the wires like I figured. All the wires have, if you look at these wires down here, they all have pins on them. So the wires don't end up fraying and getting all messy. You just remove the excess solder and then put these back in the board when you're done. And it'll turn out really well. Anyway, I'll come back with an update as I go. But I'm going to start on the amp boards first, I think. Get those knocked out. I'm also going to clean the chassis. This thing's pretty nasty. It's all the areas you can't see from the top when everything's in place, including the shrouds and the covers. And I have all the parts over here laid out. I use these trays, and I label the trays with the screws. It's a very helpful thing to do. And I have all the knobs and switch caps in this box right here. The shrouds. And then all the components up here. The new filter caps as well. Faceplate is pretty clean. I will polish it up and give it a pretty good deep clean, but as is, it's pretty nice. I've seen these where they're just disgusting, covered with scratches, but it's a good example of one where it's a good shape. Alright, I'll come back in a minute. Here's a quick view of the board up close before I begin work. You can see there's a few resistors here that have some corrosion on them. Lots of glue to scrape. These 6 wires right here lead to the outputs that are mounted to the heatsink. So what I'm going to do is I'm going to take these 4 screws out, flip the board down, and then unsolder all these wires. And and that will allow me to remove this board from the heatsink entirely, and that way I can work on it a lot easier. That little dip package right there is your input differential. It's a 2SK97 by Sony. So your signal gets routed into there, and then you have your offset adjust. You have your coarse and your fine offset adjust. I think that's what that is for your input differential. And then you have related circuitry. You know, you have your driver, your pre-drivers, and then your drivers. And that's probably a transistor in the middle is probably a bias tracker. And then you have the outputs mounted to the heatsink. And it's basically as simple as that. Some filtering for your driver stage. Very simple. I don't see any VD1212s on this board or the other board. Might be somewhere, but not on this board. I know the power supply has some VD1212s, and I think the input board does as well. So let's get to it. So these 4 screws should just come right out. Set those off to the side. And I think this one screw on this heatsink holds it to the bracket that attaches it to the main heatsink. And theoretically this should lift right up. Just like that. So I'm going to go ahead and desolder these wires from the board, and then we can take a closer look at this. So you can just see how dried up this grease is. It just wants to flake right off. You can see it all falling down on the table there. So we'll get that changed out, and we'll go from there. So here's the heatsink all cleaned up, with the outputs remounted on silicone thermal pads. It's all cleaned up. I have new thermal compound put onto this bracket right here that transfers heat to the bias tracker transistor. So now that the foundation for the amp board is all built up, let's focus our attention to the amp board itself. It's going to need quite a bit of work. So I'm back with the AU-717 amplifier card. I just finished this one up, and it looks pretty good. Lots of new components. Reflowed and defluxed the back so it looks better than new. Lots of upgrades that I did to this circuit board. New Zener diodes for your reference voltages, trimmers for offset and bias. I have new capacitors for your main filtering for the board, as well as some other capacitors on each side. I went from 470 all the way up to 1000, and then from 33 to 100 on the smaller ones. I changed a electrolytic capacitor out for a film. I have some new resistors. A couple of the fusible resistors were out of tolerance, so I changed those out with metal films. And a few areas here, the small signal diodes, I have those ones changed out for 1N4148s. These right here, I'll show you this one. This one was actually eaten from the corrosive glue, so I swapped that out, and I decided to change these two as well. So I'm going to follow that same procedure for the other board. Some of these small signal transistors down here, I have these replaced with gain match transistors. And I have the drivers remounted on new silicone thermal pads. And this brings me to a point that I just noticed a little while ago, and I'm actually going to have to remove these from the board again and take out these insulating washers that I installed. When I was first rebuilding this board, I thought to myself that it was weird how they have these two transistors, one on each rail, positive and negative. They're carrying quite a high voltage through these screws right here. And what I hadn't realized was they have the collector lead on these transistors cut. So they're actually picking up the main collector voltage through the screw on each transistor. And that then carries it from the circuit board to the transistor through the heatsink, the case. Not this heatsink, the heatsink on the heat spreader on the transistor. And I hadn't seen that they cut the collector lead and were relying solely on the screw. So I thought it was weird that they didn't insulate the screw from the heatsink on either transistor. So that would mean that if this heatsink were to shift, you had the potential of shorting the two rails together to the heatsink, which wouldn't be good. You'd blow a lot of stuff up. So what I did was I added an insulator, and once I got it all together, I realized that, like I said, there's no collector lead. So what I did basically was just isolate collector voltage from the transistor. So I'm actually going to have to undo that. Shouldn't take too long. Just pull these two nuts off, remove the washer, and put it all back together with new insulators, because those are one-time use. But other than that small issue, this actually went pretty well. The glue came up pretty easily with toluene, the stuff that I usually use. And other than that, it's ready to go. You can see the artwork on the back. Looks really good. So after I fix that issue, I'm going to remount it to the heatsink. And I'm going to move on to the other amplifier module. So I'll come back when I get that one out of the way. I'll probably come back and give you an update as I go, but kind of in the mood to just keep going and not really stop. So I'll be back in a minute. I forgot to mention a helpful tip that I have learned as I rebuild amplifiers. If I have two of the same circuit board and I know that the parts are going to be identical between the two, as I replace components, what I do is I take more than what I need. I take as many as I need for this circuit board for the next circuit board. That way I have a stockpile of parts for the next board, so I don't have to make the trip back to the parts box or the parts drawer more than one time. Just makes everything a little bit easier. Here's all the old parts. You can see the glue they used. Nasty stuff. You can see the one diode right here that had its leg completely eaten. So, alright, I'm going to keep going. Real quick update. I have the board mounted to the heatsink. It looks really good. Putting this all back together, it went together really well. It all came together, and the finished product looks really good. Nice and clean. Far cry from the original condition. And just to compare it to this one, I haven't touched this one yet. I'm about to start work on this. This one, the corrosion hasn't started. The glue hasn't really activated yet, so I'm not going to have to deal with that. But this one needs to be cleaned up as well. Pretty dirty. What's good is the original outputs haven't been changed on either of these. Nothing has been done to either of these amplifier modules or the rest of the amp, for that matter. No one's ever even removed the top cover, other than Jay, the owner of the amp, who opened it just to clean it up. But that's always a good thing. I always prefer to work on an amplifier that hasn't been touched before by anybody. It just makes the restoration and possible fault and troubleshooting, fault diagnosis and troubleshooting a lot easier, because that way I'm not chasing other people's work. It just makes everything harder when somebody who doesn't know what they're doing goes into a piece of equipment and starts messing around, because then you'll get more issues, and the failure mode, the original failure mode, isn't the only issue anymore. It's everything that the next person does on top of it that makes the job a lot harder. So it's always nice to work on things that haven't been touched before. So I'll keep going on this, and as usual, I'll come back with an update soon. Okay, so it's the next day. I have both amplifier modules all set to go, fully rebuilt. I did everything I mentioned. A couple of other things I forgot to mention where I measured every single resistor on the board, especially the fusible resistors. I paid close attention to those, made sure they were all within spec, and they're all spot on for resistance, and none of them have been heat stressed. This amplifier has actually had very, very, very little use. There's no heat stress on any of the boards. None of the components were heat stressed, and it just looks really, really good. This was a very, very good example of an AU-717 for a restoration. It's a perfect candidate. I've seen these where they're just disgustingly foul and dirty, and this one wasn't one of those. This one's just really, really great shape. Very, very worthy of the work I'm putting into it. One of the things that I do when I install these trimmers, this is a well-known thing, but some people may not know this, is when you remove the old trimmers, you want to measure from the center tap to either leg, and then you're going to want to take these new resistors and match, these trimmers, and you're going to want to match the resistance to the old ones, so that way when you fire this thing up, your bias won't be crazy high or your center voltages won't be way off. So that's always a help to do that. I didn't change this TO92 because this is part of your ASO, and if you change that and the gain is different or any of the other characteristics are different, it could throw your protection circuit off. So I'm going to leave that alone, as well as the other one on this board, but everything else got changed. So these are all set to go. I'm going to move on to the power supply next. This is going to be the most comprehensive board to work on in the amplifier. This is going to need a lot of stuff. Same stuff as these two boards, but there's a lot more packed onto this board. Every electrolytic capacitor needs to be changed. And let me just show you the corrosion damage. So those diodes and those resistors are all going to have to come out. Lots of corrosion damage. I might change these regulators out. If I can get MJ transistors in there, I'll probably do that. MJE from onsemi. Change those regulators. And like I said, new capacitors. I'm going to change a lot of these diodes, the Zener diodes that are in between these capacitors that are covered in glue. It's going to get a new relay. I'm probably also going to swap out a ton of these TO92 transistors and see about the fusible resistors on this board. I'll change them if they're out of spec. I'm going to polish the fuse contacts and the fuses. And I'm also going to reflow the back of the board as well. This is a pretty good example of a board that definitely needs work on the back side. You can see it's just covered in flux and tons of dry and cold solder joints. I'm also going to be changing out these diodes right here, all these guys, these rectifier diodes. Get those changed out. So this whole board is just going to get totally refreshed from top to bottom. I've begun removing capacitors from the board just to gain access to the glue to scrape it. And I noticed that these Zener diodes that are forming your reference voltages for your power supply rails are completely eaten through. I desoldered this diode right here, the Zener diode, and it's just, the leg just completely detached from it. So this diode wasn't even in the circuit. And I'm afraid that the other one over here is the same. So I'm surprised this power supply was working at all without these, properly that is. And I'm even more surprised that I was able to get full output from the amplifier without anything, without any issue. So it goes to show, components like this, you'll never know that they're broken until something else breaks, and then you'll have a bigger issue on your hands. So it's best to take care of these issues sooner rather than later. Same story for all these resistors. Lots of work to do on this board, so I'm gonna keep going. Okay, I'm back with the Sansui AU-717 power supply. I have just about half of this board reworked, plus a few components here and there in the protection circuit area. I have this side of the board completely stock, so I'll show you the before and after. So you can see that all these capacitors, they're old, lots of glue, lots of component damage from the glue as well. If I bend this resistor out of the way, you'll be able to see this diode right here. I'm pretty sure that's completely broken. Yep, it just wants to come right off as soon as I touch it. Same story with a bunch of resistors. On this channel, I changed a bunch of the resistors as well. But yeah, you know, the regulators, I'm gonna change these out with higher quality MJE parts. That'll be much better in place of these old transistors. Much better performance out of these, cooler running, higher power. I also have a bunch of the TO92 transistors on this channel changed as well, going from these guys right here. I have a bunch of the silicon signal diodes changed as well, a couple of Zehners here and there, the flyback diode for the relay coil. I have the fuses polished and the fuse holders as well. All the glue scraped, of course. New rectifier diodes. So, still going along. There's a lot of work to do, but I'm coming to a close on it. I just got to get this side done, and then it'll be all set to go. Minus the rework, of course. This is going to need quite a bit of work on the back side of the board. Lots of dry solder joints. And then after I'm done with all that, and after I reflow and deflux the back of the board, that's when I'm going to install the new relay. Getting a new power supply relay. Here's all the old parts. Tons of stuff. This is just from this board alone. Oh yeah, I also have some WEMA caps down here. Just bypass caps for high frequency. Oh yeah, I also have this VD1212 replaced with two 1N4 148s in series as well, right there. So yeah, very comprehensive job on this board. Most people will just recap it and maybe scrape some glue and be done with it, but I want to ensure the longevity and the durability of this power supply. So we'll make an audible difference. I can guarantee it. I'll come back when I'm all set with this board, show you what it looks like when I'm done. So it's the next day, and I have the power supply completely finished. I duplicated the things that I did on one side directly to the other, like I said I was going to do. And the finished product is really, really nice. Those new regulators are going to help out with the heat quite a bit. They should run a lot cooler. Like I said, I'm using Nippon Kimicon LXZ and LXY series capacitors for this power supply. They're some of the best you could get for power supply rolls, along with the KYB series. Those are also really nice. Very low impedance, low noise. So, I'll show you the back of the board. Basically a mirror finish on the back now. Every solder joint touched up. You can see your reflection in the solder joints. They're so shiny. So and in order to do this, you really have to take this board out. Some people leave this board in and they work around the wires. I find it a lot easier to desolder every single wire, as the wires themselves all have these snap caps on the end, so they come in or they come out and go back in very easily, especially when you have proper desoldering and soldering equipment. It just makes the job a lot easier. So I just went through, verified orientation of all the components, and made sure I didn't have any solder bridges on the back after doing all that work. And I also have the amp cards done, as you've already seen. And I'm going to reinstall the power supply and the 2 amp cards now. I just cleaned the chassis entirely. I used a foaming cleanser that I have with compressed air and a microfiber cloth. And I finished that up with a treatment of goop. This is a hand cleaner, but it works really, really well for rejuvenating metal and wood finishes. As you can see, this chassis is a really rich, deep black color now, whereas before it was pretty dull and gray. You can also see your reflection in it. It just makes the last finishing touches to a chassis like this more noticeable. So I always have a can of this on hand. So I'll come back when I get the power supply and the amplifier boards back in, and then we're going to move to the filter caps. We're going to get these changed out for the new Chemet filter caps that I have over here. These are same value, 63 volt at 15,000 microfarad. These are Chemet ALT22A153DE063. They're a little bit shorter, but they're the same diameter, so they'll work perfectly in the existing clamps for the capacitors that are already there. So, like I said, we'll come back when I am in the process of doing that. And here's all the parts. Lots of parts. This is just from the power supply. Alright, so I'm in the process of replacing the filter capacitors in the AU-717. I have 2 new filter caps installed, as well as the film cap bypass capacitors. And I'll show you the size difference between the new ones and the old ones. The new ones are the same value as the old ones, but because capacitor technology has come pretty far in the last 50 years, they're a lot smaller, which will allow better airflow. Same diameter, so they fit really nicely into the original brackets, and they're nice and tight. They don't move. And here's one of the old caps right here, right next to the new ones. And I have one of the old ones hooked up to my analyzer, and I want to show you how far down on capacitance it is. This is originally a 15,000 microfarad at 63 volt capacitor. And if I bring you up here, I can show you that this capacitor is way under. It's sitting at about 11,000 microfarad, which was too low. It's way too low. It has drifted over the years, and I think even the ESR is pretty bad as well. Yeah, I can't really make up its mind. A little while ago it was sitting at about 0.5 ohms, which is really bad. But either way, they're getting changed. And by the way, the leakage is also really bad as well. It takes a little while to do the leakage test, so I won't do it on here, but it failed the leakage test as well. So these capacitors have to go, as well as the old mylar caps that used to go across them. Those are going as well, in place of polypropylene bypass caps. I think those are 2.2 microfarad each. So I'm going to get these other 2 changed out, and we'll go from there. You can probably tell I have the amplifier modules back in. And once I'm done with the filter capacitors, I'm going to get the power supply module in as well, which is sitting somewhere around here, right up here. So I'll get that installed after I finish those, and we'll come back for either testing, or we'll come back for the input board that I'm going to rework next. Okay, I'm back with the AU-717. I have the power supply board installed with the new filter caps, and I have the amplifier modules wired in. I measured power supply voltages and everything was correct, so I hooked up the amplifier modules, and right now I'm just monitoring bias, and both channels are tracking pretty evenly, 19.7 and 19.8. So both amplifier modules are working correctly. I have a stable offset under 5 millivolts on each channel without even adjusting it. So I'm going to just get that down as close to 0 millivolts as I can after I let this thing warm up for a little while longer. But this thing is really coming out nicely. I'm very happy with how it's coming together. These are some pretty cool test clips that I picked up. They're bendable. They're made out of silicone. I picked these up on eBay. They don't really have a name. If you search long reach flexible grabber, you'll probably find it. But this allows you to get deep down inside chassis without much trouble to take measurements. And they were only like 15 bucks, and I use these all the time now, along with these ones that I've showed before, these Tektronix SMG 50s. But besides that, everything looks good so far. Power supply is nice and cool. It's been on for about 30 minutes now. Channels are nice and warm. So I'll follow up with an update shortly. I think we're going to start to work on the input board right here. So that'll be next. It's going to need a lot of work. Lots of reflow, deflux, a bunch of capacitors, and probably a bunch of transistors as well. And these terrible little VD1212 diodes that are very common in these amplifiers that cause a lot of issues. These little things right here. So I'll come back when I start to work on that. So I'm going to get started on this input board. Just the basic things need to be done. It needs a full recap. It has a couple of these VD1212 diodes on it that I need to change out. And I'm probably going to change out a bunch of the transistors as well, because I think a bunch of these are susceptible to noise, especially in the signal path, so it's best to just get them out of there. I'm going to service the switches and reflow and deflux the back as well. Here's a pretty cool tool I get a lot of use out of. This is a battery-powered micro engraver. You can charge it with USB-C, and there's a button on it. You just press the button, and it turns right on. I use this for circuit trace repair. So I'll show you, I'll give you an example. I have a trace right here that's lifted. You can see that right there. So if I solder this component down, there's a chance that over time this solder joint right here will develop a stress crack on the trace itself. So a really cool thing about this tool is you can grind solder mask with it. And I'll wipe that with some alcohol. What I do is I bend the lead down and I anchor it to the joint that's just adjacent to it. Trim off the excess and then just solder it right down. This tool works really well with bigger areas. If you don't want to use one of the fiberglass brushes like this. What I don't like about these is these are pretty broad, and you tend to do a lot of damage to the board itself. Because the tip is so wide, it's hard to get it into small areas without making a big mess. So I use this. It comes in real handy with bigger traces as well. You could change the tips out, and it works really well. So I'm going to keep going on this board. I'm just about done. I'm just changing some signal transistors out, and I'll show you what it looks like when I'm done. So I've had a lot of questions on how I deflux circuit boards, and I will show you the process right now. It's pretty easy. This doesn't apply to every single circuit board out there. There are some caveats to this method because you are getting the whole circuit board wet with alcohol. So if you have any sensitive components on the circuit board, like transformers or anything like that, you don't want to do this. But just to give you an example on this circuit board, because there's nothing sensitive on this circuit board to alcohol, I will be using this method. So I have some just rubbing alcohol here. This is not 91. I just refilled this bottle. This is 99%. This is basically anhydrous isopropyl, so there's no water in this. When you use the water, you will get a residue that gets left behind. It's like a powdery white substance that's really annoying to get off. So I really suggest anhydrous isopropyl alcohol. So what I do is I just stick the circuit board that's currently covered in flux into a Tupperware container like this. And then all I do is I just spray the circuit board and I let it sit for just a little while. So I'll leave this sitting here for the next couple minutes and I will come back. So I've applied a few more coats of alcohol to the circuit board, and if I show you how much alcohol I added, that just shows you. And you can see I haven't even done any scrubbing yet, and the water's, or the alcohol is already pretty yellow. So what I'm going to do is I'm going to prop up this container on the back side, so all the alcohol will flow down toward this side. And let's just add another little coat. And that's where I stop adding the alcohol for now, because I have all this alcohol to work with, and even when this stuff gets yellow, it still works. So what I'm going to do is I'm just going to take a paintbrush, and all I do is just go around the circuit board and scrub it all in. And eventually, you know, over time what I do is I dunk the paintbrush in the alcohol again, and that just gets more alcohol up to the circuit board where you want it. And what I do is I wear gloves doing this, because the old flux that they used to use in these amplifiers really smells pretty bad. And once it gets on your skin, it's almost impossible to get the smell out. It stays in for a couple days anyway, and it really doesn't smell very good. So gloves are a must, in my opinion. So here's the completed circuit board. Just finished the reflow and deflux process on this. You can see how clean the back side of the board is. There's no flux residue. Every single solder joint is nice and fresh, shiny, reflowed. Looks really good. It takes a little while to do a proper job defluxing, and you really need to remove the circuit board from whatever you're working on in order to do it. So on the component side of the circuit board, you'll see I have new capacitors throughout. A few of them I upgraded the values on. I have the VD1212 double diode packages removed and replaced with two 1N4 148s in series. You can see one of them right there. There's 4 of those on the circuit board. Every single signal transistor on the circuit board has been replaced with exact replacements. The original ones are susceptible to noise, so it's always good to get those out of the circuit. Usually I don't change signal path transistors, as usually they're pretty reliable. They don't really cause too many issues, but especially in integrateds like this from Sansui and a few other manufacturers, it's best to get the ones out of there, because they're known to cause issues. New coupling caps. These used to be, I think these were polyester film caps, I think. So I have these removed and replaced with polyester film. Polypropylene film, I'm sorry. And then I have some WEMA stacked film caps for the bypass caps. What else did I do? A few of the fusible resistors I have changed out with metal films. And that about does it. There was a pretty good amount of parts on the circuit board. Lots of semis, lots of caps. And I put WEMA film caps where the old coupling caps were. They had 2 polarized caps back to back to form a non-polar cap, so I changed them out with films. Those will be much better in that application, much lower ESR, higher performance. I might have to swap these 2 Muse bipolars out, because after I installed these, I noticed that this one right here is in the way of this shaft. I know that the shaft has a coupling on it that increases the width of the shaft itself, and I think it'll stop before this capacitor, but I still think this will be in the way of the actual metal shaft itself. So we'll see when I go to put it back in. If these don't work out, I have a couple of different capacitors here. These aren't bipolar. The original ones weren't bipolar as is, but I'll swap them to these. These are just Panasonic FC series. So those will work in place if these larger Muse capacitors don't work out. So I'm going to get this board reinstalled, and I will come back with an update in a second. Okay, so it's starting to look like an amp again. I just got this PCB installed and all wired in. You can see how nice that circuit board looks. Too bad it's going to be covered by shroud, but it is what it is. All new components. Here's all the old stuff. I think there were 16 transistors, 4 VD double diode packages, 4 fusible resistors, a handful of caps, and I think some other stuff as well. But this amp is really coming together. It looks really good. A lot of work has gone into this thing so far. It's been right about a week, right around a week so far. I don't have all day, every day to work on these. I have another full-time job. Audio gear is basically just a hobby for me. So it's really only nights and weekends that I'm able to do this stuff. So I'm making really good progress so far. And let me just show you the channel matching is pretty good. I'm running a small signal through this thing again. And both channels track evenly. I need to clean that balance control. That's the next board I'm going to take out. Maybe not that board. I'm going to do the small auxiliary boards first. These 2. And then I'm going to leave that for after that. And then finally I'm going to move to the back panel after all that's done. Let me turn this up on its side, show you the bottom side. The new filter caps are installed with the bypass caps on them. So I'm going to keep going, and I'll be back in just a second. So I'm working on the faceplate now. I have these 2 boards just about removed. I just have to unsolder the wires from that board down there. I just got this board put back in for the tape switches. The controls are now serviced, and the entire PCB is now resoldered. So I'm going to get these boards out, and I'll come back when I do that. So I just removed these 2 PCBs for the tone control circuit and the turnover. So I'm going to reflow and deflux these boards as well as service the controls, and then get them reinstalled. Okay, I just finished these 2 boards up. Reflowed and defluxed both boards, serviced the controls. They're all set to go back in. I'm just going to lubricate the lock mechanism on both of these turnover switches, and then I'll reinstall this, and then we're going to move to this board right here. So I'll come back when I start that. Here's the tone control PCB removed from the chassis. This took quite a bit of work to get out. There was a lot of wires that I had to desolder, You can see all the holes in the bottom of the PCB from all the old wiring. So it was a bit of a challenge to get this out, but it allows me a lot more access to the board with it removed from the chassis. So there's a lot of work that needs to be done to this board. Lots of signal transistors, capacitors, and of course the reflow deflux of the bottom side of the board, and surfacing the controls and switches. Okay, I'm still going with the tone control circuit board. I have it completely defluxed, reflowed. I have all the components replaced, including all the signal transistors. They're all gain matched. So I'm just doing the final deflux. So I'm going to keep going with this, and then I'll come back when I get it into the chassis. Okay, it's all set to go. I did everything to this board. I replaced a bunch of electrolytic capacitors in the signal path with films. I changed out a bunch of the fusible resistors. I also replaced every single signal transistor on the board. I had to gain match a bunch of those. A couple of the spots on this board had two polarized caps back to back again to form a non-polar cap. So I changed those out with polarized Muse capacitors from Nichicon. Or non-polarized Muse Nichicon caps, I should say. Reflowed and defluxed the back of the board. I mean, this is basically the same story for every single board in this amp. I don't even know why I'm making a video on every board I work on when it's all the same, but some people like to see this, like to see it in progress, so. I upgraded a bunch of the filtering capacitors for this board from, I think, 220 to 470. They actually might have been lower than that, but it's going to be much better. There was also two VD1212s on this board that I changed out with 1 and 4 1/4/8. Here's the old parts right here. I removed a couple bypass caps because I'm using films in place of electrolytics. And also have the controls and switches all serviced with deoxit. So it's all ready to go. Okay, I'll be back in a few minutes to give an update on the faceplate once I get this installed. I'm also going to clean down there, it's pretty dirty. So it's the next day. I just got all the circuit boards reinstalled into the front, the tone control board as well as the two daughter boards that mount to the faceplate. I have all the nuts that hold the potentiometers torqued down. When I first got this amp, none of them were very tight, so you could grab the shaft and you can wiggle the switches and the potentiometers within the sub chassis, but now they're nice and tight. They don't wiggle. I have every single control serviced. Everything's lubricated. Everything's nice and quiet. All the switches are dead silent, no static. Before, when I changed the balance, you could see a lot of static in the waveform, but now when I change it, it's nice and quiet. As well as the volume, they track evenly, so that's perfect. So everything is looking really good. The channels bias up, there's no offset. I have proper rail voltages. Power supply is nice and cool. No excess noise, no hum, no hiss. The noise floor is lower than it was when it came in, so that's always a plus. So now that everything is working properly, everything's nice, staying nice and cool. The channels are warm. We're going to move to the back panel now. So I'm just going to verify just a couple more things, and then I'll come back when I get to the rear. But for now, this thing is really coming together pretty well. Getting rid of all those electrolytics in the signal path is really going to help out. Here's the rear panel of the AU-717. There's quite a few things to do. Starting with the RCA jacks, I have to pull the circuit board out and polish every single one of these. They're all pretty oxidized, and it's really tough to put on and take off RCA jacks. You could see some of the corrosion that's been removed just from putting the jacks on. So lots of work there. The speaker jacks I'm going to be replacing with 5-way binding posts. I have a retrofit set coming from Europe. They're a direct drop-in replacement for these. I don't have to make any fabrication plate or anything like that. Just pop these out and put the new ones in, solder them in place. And also the IC inlet. I'm going to take this off and put an IC inlet on there. The preamp, main amp switch, there's a circuit board, and that has coupling caps on it that I'm going to be replacing as well. And I'm going to be completely redoing both of these circuit boards as well. So like I said, quite a bit of work, but this is one of the last pieces to the puzzle. So let's get to it. So I'm in the process of removing the pre-out and power amp in circuit board with the coupling switch down here. The switch is attached to the bottom side of the circuit board, and it's held into the rear plate with 2 screws. But the RCA jacks are soldered to the board, and they're held to the rear plate with these plastic rivets. And anybody who's worked with these before knows how tricky they can be to remove. I've seen people damage rear plates using metal screwdrivers or metal tools to get under there to lift them. And in this case, the rear side is actually glued. So you can't really do much in terms of pushing the pin through the back side. You'll end up just breaking that side of it. So I have a really cool set of tools that I use, not only for these rivets, but I use these for switch caps and knobs on faceplates. This kit is from Snap-on, and it's part number PPBM300. I've shown this in another video. I think it was the Sony video to remove knobs. But this kit is fantastic for these plastic rivets. These are made out of fiberglass reinforced nylon, I'm pretty sure. So they're really tough, but they won't scratch the equipment that you work on. So if I just come under here with these 2 little pry bars, it's kind of tough to work around the camera. Just bear with me. Yeah, I should have thought this one through before sticking the camera in front of here. But let's just start one of them. Try to zoom in on this too. I got 2 out pretty easily, but as soon as I stick the camera in front of this thing, it starts to become a challenge. So once you work around the rivet just a little bit, it'll start to lift out of place. And then you'll be able to get under both sides of the rivet with these tools just like that. And all you have to do is pry it right out equally. And you can see that the rivet will just come right out. Just like that. Really tough to work with, but if you're careful, you'll get the job done and you won't damage the rear plate of whatever you're working on. Those little smudges right there are just smudges. You can just polish those out. It's better than chipping the paint with a metal tool like this. Okay, here's the pre-out and main in jumper board from the back panel. I just got this one out. This is just going to be a pretty quick job. They have 4 polarized capacitors, 2 each back to back to form a non-polar capacitor for your interstage coupling between your preamp section and your main amp section. So I'm going to be replacing these 4 capacitors with these 2 films right here. These are polypropylene films, 2.2 microfarad. These will be much better in the signal path, much lower ESR, lower noise, better linearity. I'm going to polish the RCA jacks and service the switch. I'm also going to beef up these solder joints back here where the mechanical connection for the RCA jacks is. Over time, when you unplug and plug the stuff in, it tends to break these solder joints. So I'm going to take care of that right now, and then take care of the rest of them while I'm at it, and then deflux the board, and then it should be good to go. So I'm going to do that, and I'll come back when I finish. Here it is all set to go. I have the 2 new film caps installed, the switch is serviced, and I have the RCA jacks nice and polished. And I have the back of the board reflowed and defluxed. So it's ready to be reinstalled. I'll come back once I get this board in and get this one out. Actually, there's two boards here, so I'll take care of those. I had another question of how I polish RCA jacks. I use a 9mm socket, a microfiber cloth, and a polish called Simichrome. And all I do is I get a little bit of it on this microfiber, and I put the socket up against the microfiber cloth like this, and this way the socket fits around the RCA jack nice and tight. And all I do is rotate this about 10 to 20 times, and it comes out looking brand new. Just a helpful tip. I see people using wire brushes and deoxit, and that may work, but you run the risk of damaging the rear plate of your amplifier with a wire brush, and deoxit just takes way too long, and it doesn't get all that deep pitting off like the Simichrome does. So, another helpful tip for you guys that want to do this yourself. Okay, I just got this board reinstalled. And while I had it out, I also polished the rear plate, so you can see my reflection basically in this versus the dull reflection over here. So this portion, when I remove these RCA jacks, I'm going to do the same to this side over here. But you can see the difference in the RCA jacks. That's pretty notable. And when you go to put RCA jacks on, they're going to be a lot easier. They're not going to want to stick on there. So I'm going to keep going. I'll come back when I finish these and get these reinstalled. And then we'll move to the IC inlet. So here's the rear plate. I have it reinstalled just temporarily. I have it all polished up. You can see just how shiny it is now. I got a lot of nicotine staining off of it and smudges and dirt. I have the IEC inlet installed and all wired in. And I have the RCA jacks all polished up to a mirror finish. You can see just how good those look comparatively to how they used to be. And I even polished the ground point on the back. So the last step on this side of the amplifier is the binding posts. And yeah, that's all I'm waiting for. We're going to move on to the adjustment and testing of the amplifier now. And then after I get that out of the way, we're going to do cosmetics. We're going to do the top plate, bottom plate, and the faceplate, and knobs and switches. And then this amplifier will be good to go. Okay, I have the AU-717 flip back around. I'm about to start doing the measurements of the amplifier, but I just want to show you guys the rebuilt circuit boards toward the back that I did. Same process on these ones, reflow and deflux. These ones were pretty bad. There was lots of dry and cracked solder joints, especially because the mechanical connection back here with the RCA joints over time just likes to crack the solder joints. So redoing those will improve the reliability of this amp that much more. So now that these are all set, the back panel, all that's left is the binding post, which I'm going to do when those come in. Those are shipping from Europe, so they're going to take a while to get here. But yeah, this thing looks really, really good. And it's also performing really well so far. The channels are sitting under a millivolt on both sides, stable. And that will change with temperature and as airflow passes over these two dip packages down here, but that's pretty normal. When the case is on, it'll be much more thermally stable, which is always a good thing. But for now, under a millivolt, I mean basically close to zero. That's basically as close to zero as you can get for an amplifier like this, which is perfect. So I'm going to hook up to my bias test points and just measure my bias pretty quickly, make sure that's still good. The service manual calls out a bias voltage of 20 millivolts across these two test points, 2 on each channel. So once I verify that, I will move to the cosmetics and I will pick up the video when I get to that point. But so far, so good. The faceplate's over here. I'm probably going to start off with this. There's maybe one or two little nicks here and there, but nothing too bad. This faceplate's basically, I would say 9.5 out of 10 condition. It's really, really nice, and it's going to clean up really well. Lots of smudges on it, but nothing too bad. You can see all the nicotine staining and the dust. So all that's got to come out. Top cover is pretty bad too. And the bottom cover is where a lot of the dirt is. You can see all that. So let's get this out of the way and move on to the cosmetics. Okay, I'm just getting back to this 717 after the past couple weeks. I haven't had a lot of time to work on gear. I've been very busy with other things, including work outside of the audio repair hobby. So I think where I left off, I was moving to the cosmetics of this amplifier. I've since cleaned the faceplate and the knobs and the switches. I've finished the interior of the amplifier. It looks really, really good. Just gorgeous. And I've also put the binding post on the back. I'll try to spin this around carefully so I can show you. So you saw the IEC that I put on. And here are the new binding posts that I put on as well. I was also waiting for these to come in. These took a couple weeks to come. They're from a website. I'll put a link in the description. It's something like speakerterminals.com or something like that. But they're based out of Europe. And they took quite a while to ship. I actually had to send them an email. And as soon as I sent them the email, they forwarded me the tracking information. And from there, it probably took another 5 or 6 days for me to get them, which isn't that bad from Europe. So they're very high quality. The mounting is anyway. The actual banana terminals themselves are, they're all right. They're a lot better than the spring clips that were here. I would have liked to see a fully metal speaker terminals, but these ones are good, not bad. They're non-magnetic, so they're either brass or some sort of non-ferrous metal. But yeah, I have the RCA jacks cleaned up. I have the back plate polished as well. Nice and shiny. And my sticker put on. So other than that, this thing's basically ready to go. But I will tell you, I have an issue where this transformer is buzzing. And it stopped me dead in my tracks because an arcing transformer is a death sentence for an amplifier like this. But I actually traced the issue down to the power switch up front. I have to pull the faceplate off and take the power switch out, and I have to clean the contacts because that's where my issue is. If I cycle this switch with the unit unplugged multiple times and I plug the unit back in and turn it on, I can't replicate the issue. But if I hold the power switch in a certain position, I can get the transformer to start humming, and that indicates a high resistance across that power switch. So that's going to be my issue that's causing my transformer to hum. And it's weird, it only happens on one transformer, but I'm positive that it's not the actual transformer itself. So I'm going to get the faceplate back off after I just put it all back together, pull the switch out, and I will measure the contacts, first of all, make sure that it is indeed the switch. And then what I'll do is I'll see if I can open the switch up, clean the contacts, and then I'll put it all back together. There is a chance that I won't be able to open the switch up, but it is an ALP switch, so it should be serviceable. I just have to verify that when I pull it out. But that's going to be the last step that has to be taken, and this thing will be good to go. I'm just hoping it's not the transformer. I'm pretty certain that it's not because I can get the issue to come and go just by wiggling the switch. So we'll see. But other than that, like I said, this thing's looking really good. So I'll come back when I have an update when I get to that point. So here's the 717 I'll put back together for the second time. I worked on this a couple days ago, got it all back together, and verified the issue was fixed. It turned out to be a faulty set of contacts in the power switch. I had the switch out. I found that the contacts were completely carbonized, and the resistance across the switch was about 5 to 10 ohms, depending on how much I wiggled the switch. Sometimes it even jumped up past 100 ohms. So I polished the fixed set of contacts in there, and I also flipped one set of contacts around. So we're now utilizing an unused portion of the contacts that were from the factory. So now this is almost like a brand new switch. It's going to last another 40 years or so. So that's good. That's all set to go. No more noise in my transformers, no more drama with the power supply now. Everything's good. The action feels good now. I lubricated the switch as well. So everything's good to go. It's going to be a really, really nice amplifier for TJ. I'm really happy for him to hear it, try it out in the system. And it's a really good looker too. Everything's so nice in this thing. It's like a brand new amp. And just to show you, here's all the parts that I changed out. I might have already shown this before, but lots of capacitors. Close to 80 caps, not including film caps as well. If I include film caps, it'll be over 100 caps that I changed out. Tons of signal path transistors, diodes, resistors, trimmers, all the insulators for the drivers and the outputs, and the regulators are also sitting on new sill pads as well. The bypass caps, or I'm sorry, the coupling caps for the rear panel. Here's the old power cord and the string clips as well, and the filters. So yeah, hopefully I can say this is the last time the cover is going to be off for the next 30 or 40 years, hopefully. This thing should provide many, many years of good service now that I've completely gone through it. So I'm going to get the top cover on, and I'll throw this into my system just for a quick demo, and then that'll do it for the video. 717 is installed into the system. I have the top cover installed, and I put the rack ears on as well. They really complete the look of the amplifier. Definitely prefer it with the rack ears on. This thing looks like a beast. And it's in really good shape too. As I've said before, this thing is cosmetically near mint. The binding posts on the back came out really well. I'm using some Kimber cable right now with them. And the RCA jacks I wanted to show you. With these polished, the plugs go on and come off very easily. There's no fighting it. There's no potential risk of damaging the RCA jacks or the plate that holds them in. So it's a good side effect of cleaning and polishing RCA jacks like that. All the controls are lubricated and cleaned. All the selection is noiseless. There's no static in the channels, no dropouts. Balance control is now clean. There's no more noise. The volume control tracks evenly between the channels. Phono stage is dead silent, as is the tuner and the auxiliary. So this thing's ready to go. And it sounds really, really good. So I'm really, really happy. I'm excited for TJ to get this thing back and put it in his system and take a listen. Definitely have a feeling this thing will give other amplifiers, even new amplifiers, a run for their money today, for sure. I'm using it with a pair of Sakara Metronome 7s with the T9s and the 8Ws right now. And this pairing sounds really good. Really, really good tonality. So I'm going to end the video here. I appreciate the support and the likes and the comments and the shares. It just keeps me going doing videos like this. I really enjoy seeing feedback from the community on work that I do. So Stay tuned. I have some more equipment in the queue ready to be worked on, a bunch of VFET equipment as well, so that's going to be pretty interesting. As for the lack of videos recently, I work on equipment nights and weekends. I have a full-time job that's out of the audio field, so the only time I really have to do this is, like I said, nights and weekends. And a lot of weeknights I'm just too tired to work on equipment like this, so usually it's just weekends. But I try to get a few pieces done a month at least, you know, full restorations. So anyway, thanks again for watching. Be sure to keep uploading videos like this. I know they get a lot of support, so until next time, thanks.